All right, so when fresh lemonade is a solution of water, lemon juice, and sugar, okay, there is a limit to how much sugar that can dissolve in a given amount of water. Once the limit is reached, you cannot make the solution taste any sweeter. So if you ever made Kool-Aid, or in this case lemonade, you know that if you put, and sometimes even coffee, if you put too much sugar in it, what happens? Huh? It gets sweet, but eventually the sugar just falls to the bottom. Not all of it gets dissolved into the water. So there is a limitation. So how are solutions with different amounts of solute described? Well, solutions described as saturated, unsaturated, or supersaturated depending on the amount of solute in the solution. Okay? So the maximum amount of a solute that dissolves in a given amount of solvent at a constant temperature is called solubility. Solubility is usually expressed in grams of solute per 100 grams of the solvent at a specified temperature. So salt, you could dissolve about 36 grams of salt into 100 grams of water, or 100 cc's at 20 degrees Celsius, which is room temperature. Okay. Baking soda, you could do about 9.6 grams. And then table sugar, 203.9 grams. So you can put way more sugar than you can salt, and very little baking soda. By the way, this is one of your questions. This PowerPoint presentation is also shared in Canvas. I know I'm recording the video, but this is one of your questions. It's going to ask you the order in which these things, which one can hold the least, which one can hold the greatest. So a saturated solution is one that contains as much solute in the solvent or as the solvent can hold at a given temperature. At 20 degrees Celsius, 203.9 grams of table sugar will dissolve into 100 grams of water. Think about that. Double the amount of sugar dissolves in the water. If you add more sugar, it won't dissolve. So if I put 210 grams of sugar in 100 grams of water, 7 grams will just fall to the bottom. Okay. Unsaturated solutions, that's less than the maximum, basically. As long as the amount of solute is less than the solubility at that temperature, the solution is considered to be unsaturated. So sugar is 200 grams. If I only put 100 grams of sugar into 100 grams of water, then it's unsaturated. Saturated is the brink. That's the most amount it'll hold. Now, supersaturated is one that contains more solute than normally can be held at a given temperature. A solvent can sometimes dissolve more solute than you might expect based on its solubility. If you heat the solution, more solute may dissolve. Carefully cool the solution without jarring it, and the extra solute in the solution remains. Okay, so basically it needs a little bit extra energy to break the bonds or help hide the molecules in between each other. And then if you carefully cool it, those molecules can remain dissolved. But if you don't carefully cool it, the extra stuff will fall to the bottom. So supersaturated solutions are very unstable. When a single crystal of sodium acetate is added to a supersaturated solution of sodium acetate in water, the excess solute rapidly crystallizes. So this is kind of a cool thing. Maybe I'll do a demonstration on that. But you can supersaturate the solution and then add one crystal, and once that crystal is it's kind of like a seed. Once it starts that, all the extra stuff will crystallize. So what factors determine the solubility of the solute? This is another one of your reading guide questions. 3 factors that affect the solubility of a solute are the polarity of the solvent, the temperature, and the pressure. So polar and nonpolar solvents. Oil does not dissolve in water because oil molecules are nonpolar and water molecules are polar. Solutions are more likely to form when the solute and the solvent are either both polar or nonpolar. Like dissolves in like. A soap molecule has a polar end, which attracts the water molecules, and a nonpolar end, which attracts the oil. That's how dish soap works. The dish soap, the molecule itself has one end that has a little polarity, the other end does not. Oil attracts to the nonpolar end of the soap molecule, and water attracts to the polarity or the polar end of the soap molecule. So generally, the solute is more likely to dissolve in a like solvent. Okay, polar with polar, polar with nonpolar, not likely. Nonpolar with polar, not likely. Nonpolar with nonpolar, more likely. So soaps and detergents are used to remove grease and oil stains, and we use water to do that. And so here, the red with the two white dots, those are water molecules. This brown stuff is grease, and the green stuff is the soap. So the soap will be attracted to the water on the polar end and be attracted to the grease on the other end. That's how soap works. Temperature. In general, the solubility of solids increases in the solvent as the solvent temperature. I think they meant to say solutes, but as the solvent temperature increases. In general, gases become less soluble as the temperature of the solvent increases. Pressure. Increasing the pressure of a gas increases the solubility of the liquid. The pressure of CO2 in a sealed 12-ounce can of soda at room temperature can be 2 to 3 times the atmospheric pressure. That's why when you open a bottle of pop, it goes psst, it releases. It's because it has way more carbon dioxide in it, and when you open the bottle, the pressure releases it. Now, they do that kind of on purpose. It's part of the process of making the pop, but also the pop goes flat. So they put a little extra in there so your pop doesn't get flat after you open it. What are the 3 ways to measure the concentration of the solution? Well, the concentration of the solution is the amount of solute dissolved in the amount of solution. Concentration can be expressed as a percent of volume, percent of mass, and molarity. So this is also a reading guide question. Percent by volume. Most bottle or canned juices are made by adding water to natural fruit juices. These solutions are less concentrated than natural fruit juices. I don't know if you've ever made juice before, but to make a glass of orange juice takes like, I bet you 20 oranges. It takes a lot to squeeze it. Now, that's highly concentrated, but a lot of times the juice that you buy off the shelf is watered down a little bit. So the percent of volume is a way to measure the concentration of one liquid. So this one says contains 27% cranberry juice. That means that 20% of the juice, 27% of the solution is the cranberry juice versus the other stuff. So here's an equation. We'll do a worksheet on this, but basically, you define the percent of the volume. You just take the volume of the solute over the volume of the solution and multiply by 100. Okay. Same thing for mass, except you're going to carefully weigh both items. It's the mass of the solute over the mass of the solution. Now, notice that it doesn't say solvent. That's the solution total. Okay. Molarity is a little different. It's the moles of the solute to the liters of solution. And like I said, we'll do a worksheet on all that stuff. To make 1 molar solution of a sodium chloride in water, that's salt, first calculate the molar mass of the solute. Sodium chloride has a molar mass of 58.5 grams. If 58.5 grams of sodium chloride is mixed in enough water to make 1 liter of solution, the resultant solution is 1 molar. And like I said, we'll do some problems with that. So 1 liter of 1 molar sodium chloride solution contains 58.5 grams of sodium. And we'll do some math on that. That's it for today. Here we got a couple math problems, but I'm not going to do that. We're just going to go and end it. Does anybody have any questions on anything?